Hi, welcome you all to Open Source 101 talk today, and I hope you are having a great day. I'm Kavitha. I work at Capital One. I started my career in the engineering space, building TICs for a decade, and I found my passion in cybersecurity and been in the product security space for a decade now.
Hi, I'm Srinivasan Rangaraj. I'm also with Capital One, and I've been in this industry for IT industry for past 25 years. Focusing on application security and engineering. And for the past 6 years, I've been in the product consulting space. And I have around 5 patents that are cyber security related. Thanks, Kavitha.
Thank you, Srini. And why we are here today, we are going to talk about, in general, about supply chain attacks, and followed by how a platform like OWASP dependency track could help mitigate risk. Followed by Srini is going to cover supply chain attacks in mobile apps, and finally conclude with the supply chain frameworks that you can use. As we all know, COVID had fundamentally transformed how the way we live and work, how the companies interact with customers, how we shop and buy, so the digital and the supply chain function. So as the innovation is accelerating, so does the cyber attacks. You wouldn't believe in 2021, developers around the world requested more than 2.2 trillion open source packages, with that is a 73% growth, right, of downloads. And as you see on the screen, the supply chain attacks are increasing exponentially. In 2021, like as mentioned by the Sonatype report, there is a 650% increase in the software supply chain attacks. All these are aimed at exploiting the weakness in the open source ecosystems. So what is supply chain, right? Like anything traditionally, like, supply chain is you needed to deliver a product, include all the components that you use. For example, if you buy a chocolate at the store, list of ingredients, packaging, anything that can affect the delivery of the product. Swapping from chocolate to the code base, a software supply chain is like anything that goes into your code from the development to the CI/CD pipeline until it gets deployed into the production. So it's everything in the software, the code, binaries, the components, where they came from, like the repository manager or a package manager. So your software supply chain risk are inherited from the dependencies. So why does it matter for security, right? So it's common that your projects like use hundreds of open source dependencies. So if one dependency, say, has a vulnerability, then chances are you have a vulnerability as well. So the first and foremost that I would think is like you have to map your application dependencies. You need to be aware of your application dependencies. Now I want to introduce the concept, or what is software bill of materials. So software bill of materials is nothing but it's a list that has all the open source and the third-party components listed. So basically just list the licenses that govern those components, the versions of the components used, and the repository, like a PURL, which we are going to see in detail how the SBOM will look like. But that's about SBOM. And with the increased security breaches, there is a cybersecurity order providing some guidelines on how do you secure software. And among the recommendations, like one of the requirements is like around the SBOMs to ensure the safety and the integrity of the software. And there are a couple of specs that are in place, and the one that you're going to see today is the Cyclone DX, which is the lightweight software bill of materials specification designed for supply chain component analysis. Now moving on to dependency track. So dependency track is an intelligent component analysis platform that allows organizations to identify the risk in the software supply chain. So it is unique, and it's leverages the SBOM. So with the dependency track, you can monitor the component usage across all the versions of all the applications in its portfolio to proactively identify the risk across our organization. And this platform is an API first design, and it's ideal for CI/CD environments. So now, as you see in the picture, how do you operationalize it? Like the first one you see is the BOM production, right? Like the first you have to create a dependency SBOM. And using the Cyclone DX spec, you can create it, which I can show you a little later. But once you have that SBOM, which has all the components listed, then this has to be ingested in the dependency track. And that could be like via REST API or a Jenkins integration, or as simple as you go to the UI and upload the BOM file. So once that is done, the dependency track has built-in analyzers. In fact, there are multiple analyzers that analyzes your components for security, operational, and the licensing risk. There is also a continuous monitoring, right? It is not just one time like you're scanning, it's a continuous scanning process going on. And also you can integrate with the real-time streams, like a notification system and also vulnerability aggregation platforms. So now let me talk about where does the intelligence come from? And one of the main database is NVD, National Vulnerability Database. So this is the publicly largest available source of vulnerability intelligence, and it is maintained by NIST. Vulnerabilities in the NVD are called CVE, which is like common vulnerabilities and exposure. And there are 100,000 CVEs documented in the NVD. And not only this dependency track is integrated with NVD, it is integrated with like GitHub advisories, like it can act as a centralized vulnerability intelligence specific to GitHub projects. And also like SONA type OSS index, right? So a majority of the vulnerabilities, like you could map it back to the CVE, but there are some unique vulnerabilities in SONA type OSS, which is not available in NVD is also found, right? So this huge integration gives you a like integration with multiple vulnerability intelligence platforms is beneficial. And yeah, now we're talking about the dependency track ecosystem, right? It also has the concept of repositories. Now you can ask me why, what is the purpose of this ecosystem integration? The primary use case for this is like identification of outdated components. So not only this dependency track can provide you the vulnerabilities in this integration with the intelligence platforms, but also it can provide you a view of outdated components. And as you all know, that outdated components also possess some risk, and that is achieved by having this integration to this different repositories like NPM and other ecosystems. So now moving on to the dependency as such track tool, you can upload your projects, scan, and you need a database to store your scanned results, and that is, and dependency track provides an embedded H2 database for your local testing, and also you can use the other support like Microsoft SQL Server and Postgres, and this tool is integrated with the LDAP. As you see on the screen, how do you create a BOM file? And it's as simple as like in the command line, you can issue these commands. For example, if you are in a Maven repository, you could issue this MVN Maven plugin make BOM under your project space, and that would literally create a BOM file with the list of all components. And if it is a node, there are a couple of commands. So it's really like simple to create a BOM file. And there are a couple of fields like type, publisher, group, name, and version. I can show you a sample BOM file. How does it look like? For example, this file talks about in a project that has a prettyfile.xml and the version of it, what is the hash for the integrity of the file and the licensing. And then, as I said, the PURL, this is the repository integration that we are talking about, package, NPM, it's coming from the NPM, and this is the version. And this is used to bring the outdated component actually. And this one, how do you get started? It's as simple as like, there is a WAR file be there, then you just like extract your WAR file and you can start in a port, and all that it takes is like just the start your server, and you can launch the dependency track. So now moving on to it, how do you create a project? This is a kind of UI. You go create a project, you give a project name and the description. And from the commands that I've showed you before, say, for example, you have a Java project, you create a BOM file. So I'm just walking through your scenario. Manually, you create a BOM file and you upload a BOM file. And the vulnerability analyzers are, sorry, there is analyzers running on the background, which will take a couple of minutes, connect to all the intelligence that we have talked about, and brings you a list of results, scan results that identifies the vulnerable components, which is used in your project. And the portal something looks like this, right? So it lists all the libraries, the versions, and the group that it belongs to. And yeah, so, and the licensing issues, and then the vulnerabilities, you can have a view of the vulnerabilities, like if it's high, medium, critical, and low, and how much are those. And the dependency track scan for vulnerabilities. Not only it provides the list of vulnerabilities, it also gives you a licensing issues. So that is what this screen depicts. And this, you can have a portfolio of project. And this screen, I wanted to show you how you can define a portfolio of vulnerabilities, right? Like for the vulnerabilities for the portfolio. So under the portfolio, you can have multiple projects, and it also gives you inherited risk score and what are the projects at risk, and number of vulnerability components at that portfolio. So you can have a better visibility on the risk factor. So now dependency track auditing, right? Once the scans run and you find all the vulnerabilities, now the project auditing, right? It is a process of triaging the components. You go triage, and the audit decisions you can capture in the tool, whether it is exploitable or it is a false positive. Maybe you are this library is vulnerable, but the function actually what you're not using the part which is like the vulnerable code, probably you're not consuming the code. So all that analysis can be done, and you can mark your auditing process. And I would like to see, like just stop here and talk about the vulnerability analysis and the outdated component analysis, right? So vulnerability analysis, as we see, there are multiple sources of intelligence coming in and finding the vulnerable components. And there are multiple analyzers are integrated, like OSS Index and VulDB. Outdated component is like you don't have those known vulnerabilities, but these are not on the latest release, right? But these are also produce the risk. So the advice here is like you have to keep those components like consistently updated. That is recommended, and this tool provides you a view for that. And the dependency track, it can be integrated with the CI/CD pipeline. So it is an analysis performed against the component. So whatever, it's a REST-based API, and it can well integrated with the Jenkins platform with the dependency track and Jenkins plugin. And as I see you in the screen, the job configuration, it's as simple as a job configuration that you say, hey, it's an artifact, and your type is like software bill of materials. And then your Jenkins CI/CD can be integrated with that. So now moving on to impact analysis. So now we have all these vulnerable components, like you do it, but what is the impact analysis that you can do? For example, it can help identify all the affected components across the organization, right? For example, if you are simply looking for, hey, like this is my struts 2.3.5 library, what are the CVEs associated with it? You can do that. And also, like, say you have a CVE, like a zero-day exploit coming in, you have a CVE published, and then you can search with that. After the scanning, you can search with the CVE, and then it will list you like the list of projects that is getting affected. So you have that impact analysis can be done here. So it can help organizations answer two important questions: what am I affected, and where am I affected? So, and also like if you want to take it further, it can even useful in performing the vendor risk assessment in identifying the potential third-party software. So you can, in the mature vendors, if they have a BOM file, all you have to do is upload, and then you have the visibility of the vulnerable components that they are using it. So it can help you identify this third-party vendor maturity also. And yeah, I wanted to just like summarize like these component analysis is a process of identifying the potential areas of risk from the third party usage and open source software and hardware components. And it is all part of the CSCRM framework. I wanted to conclude my part with explaining you the dependency track ecosystem. As you see, the first is production of BOM using the Cyclone DX spec, and the tool dependency track is very well integrated with the multiple vulnerability intelligence platforms, and it supports multiple repositories like popular repositories like Maven, NPM, PyPI, and notification platforms like Slack and Teams can be used to communication, and it's API first design with CI/CD Jenkins support. And also it can be aggregated with the multiple vulnerability aggregation platforms like ThreatFix and Kiana. With this, I kind of conclude my portion, and Srini, you can take over.
Thank you, Kavitha. I hope you're able to see my screen. Yeah. So I think Kavitha covered in detail about the bill of materials, the dependency track, and tooling. But my focus would be on the mobile applications and the supply chain attacks, right? Primarily, what is happening today is the attackers have shifted the attacks from the production apps to the engineering or the CI/CD pipeline. So what does that mean? So it becomes an easy task for the attackers or the malicious actor to get into the CI/CD pipeline, either by compromising a developer's account or injecting a malicious code on the open source code that the developer is using, or they can compromise the build process. So it becomes very easy, and they can take control of the production app when the app or the app is in the production system. So it becomes like a backdoor for them, and they have easy access to the sensitive information or to carry out some root cause and remote code execution. Right. So in this talk, what I want to focus is not just the tooling, but I also want to touch base on all the best practices that we can incorporate when we are leveraging open source and third-party components. So before I go into the details of this, I just want to highlight what the mobile app ecosystem looks like. So let's start off with the mobile app in the first space. So the mobile app contains open source components that the app developer would be using. Similarly, the app developer might be using a third-party SDK, and the third-party SDK might be using open source components. Open source components are great because it has so many eyes looking into it. There is a lot of improvements on the open source, and that's why we heavily use open source components. But at the same time, there are few malicious actors who could be capitalizing on these open source by injecting malicious code. They can do this through typo squatting or dependency confusion attacks. So now this is a production app where we have the open source component and the third-party open source SDK embedded within the app. But now let's shift focus on to the CI/CD pipeline that Kavitha was mentioning about. If any of these processes, starting from requirement, design, development, testing, and deployment, has a dependency, it could be a dependency on open source or third party, If any of these design, development, testing, or deployment phase is compromised, there's always a potential for a malicious actor to inject a code that can be leveraged at a later point in time when the app is in the production environment. So here we also have to note that with dependency doesn't just mean the open source dependency, it is also a dependency on the third-party services. So what we have to essentially see is how is your third-party SDKs being integrated in the production system? Does it have a dependency on the third-party service? And how does the third-party service protect their SDLC process or their supply chain system? And the third-party SDK service provider might also be integrating with the fourth party. So there is always a potential of a supply chain attack through the fourth party. So with that, coming back to this particular framework, so as you can see, I have come out with the best practices. So within your organization, if you're a startup or an enterprise, you can probably use NIST or Google SLSA framework for the best practices for preventing any supply chain attack. So this is more from a framework or a process standpoint. You can leverage this. In addition to this process, you have to make sure all your access control to your CI/CD is hardened, and entire CI/CD pipeline should be hardened. There should not be external access into your CI/CD pipeline. So no malicious actor could come and infiltrate into your CI/CD pipeline. Similarly, monitoring is very important, right? So as Kavitha was mentioning about vulnerability scanning and patching these open source components or third-party components within the CI/CD pipeline becomes very important. So there should be an ongoing monitoring, vulnerability scanning, and patching. This is very, very critical. She also mentioned about validating these dependencies with hashes or signatures. So we need to make sure that all your artifacts have proper provenance with proper digests. So these validations should be happening from the design phase, during the build phase, during testing phase, and deployment phase, just to make sure your integrity is not impacted. In addition to this, a constant testing from a supply chain side of things should always happen. This can happen with the help of a red team that focuses specifically on supply chain components. It could be open source, it could be third-party components as well. It can include the GitHub scans, or it could have binary scans. So everything has to be automated using your CI/CD pipeline. And last but not the least, we have to have a provision to disable open source components from your app in case of a worst case scenario. Say, assuming there is a 0-day attack that happens on the app, then from a server side, you should be in a position to disable this particular feature from your app. So moving on, some of the questions that you need to ask. Open source is used widely in all the mobile applications today, right? So if you're a startup, you want to build up an app, you're not going to start from the scratch. So there are so many good open source components available in the for you to build. But what is important is you need to see if these open source components are where from they're coming, right? Is it coming from the right source? So because we have multiple FTP mirroring sites, so make sure that you get your open source component from the right source. Does check if it has got good documentation. Does it have recent commits? Also make sure that they have proper signature validations, and also check for CVEs and check all the commits that have happened. Right. So and try to get it scanned with the help of a couple of eyes, not just that you just bring it down into your GitHub and give a chance for a malicious code to be injected into your source repository. So these are very, very essential, because we focus so much on the source code that is developed in-house, but focus is not about how the open source licensing or the open source component which is brought from the internet, no much focus is given. So I emphasize that you have to focus on the open source or third-party components that you bring from the internet. So this would be a great starting point. So please refer to the DIST mobile threat catalog. So it talks about various threats that could happen on the open source, specifically from a mobile standpoint. So I have highlighted few of them. For example, there could be malicious code in open source software, malicious software inserted into the software processes or tools, malicious code in custom software, malicious software and third-party bundling process, right? So all these are very, very important for us to make sure that these are carefully thought through, right? So I will just pick one example, malicious code in open source. So we have to understand two things. One, a open source can be vulnerable to attacks, and the other is a malicious open source. A malicious open source is something a malicious actor has injected a code into the open source, either by compromising a maintenance, a open source maintainers account, or taking over their account and pushing this malicious code, or they are creating some packages with identical names. So a developer who's pulling this information might be misunderstanding that this is the right repository by typo squatting attack. So the malicious code could become a backdoor. A vulnerable open source can be susceptible for 0-day. So just I want to call out the distinction. So here what we are saying, what NIST recommendation is, you have to check for integrity checks. So I think based on Kavitha's dependency track, one of our ask was to make sure that we do an integrity check. So like signatures or hashes throughout the SDLC process. Check for multiple instances of the same library. Evaluate for versions for consistency. That's very, very important. As I mentioned in the previous slide, testing during runtime becomes very critical, and a dedicated team like a red team would be really required, especially to defend against supply chain attacks. And ensure your open source library is tamper-proof, and perform enough functional tests to make sure that product provides consistent behavior. With that, now let me focus on the SLSA framework. So I'm not advocating that you need to stick to SLSA framework, which comes from Google, because Google has tried this for past 8 years within their own organization, and they are now providing this particular framework to external to the entire world to leverage it. And what I'm saying is, you can probably take the best practices from the SLSA framework, which is the supply chain level of software artifacts. So this provides you with the guidance on how you can handle your supply chain attacks. So we all know about what happened with SolarWinds and other attacks. So based on Gartner, by 2025, 45% of organizations worldwide will have experiences in attacks on their software supply chain attacks. This is a prediction from Gartner. So it becomes very, very important for us to have the visibility of all the toolings that we have in our environment, and understand what are the limitations of the tools, and how tools can be an attack vector for the malicious actors. And the key is, how do we protect our artifacts, right? So with that, I'm just giving you an example of what could go wrong in your entire SDLC process with the dependencies, right? So what could go wrong? So as a developer, I get all my requirements from the product team, start developing it. So I do my check-in, or as a developer, do the check-in. and there would be a pull request, and there is a potential that a code review can get bypassed. So these are all source threats, right? Compromised source control system. Your source control system can be compromised if your CI/CD is not hardened. Let's come to the build process. So there is a potential for a modified code to get into your source code, or there could be a compromised build platform, or the build platform can be bypassed if you're not managing your external connections through proper firewall rules and through proper VPC controls. You might get exposed to the external world. Similarly, your integrity of your package is very, very important. So there's a potential for the package to get corrupted using by a malicious actor or an internal attacker. And the chances of leveraging a bad package is the most common one. So we have to make sure there are a couple of eyes watching for any bad packages, and you may have to do some scripting to make sure that you don't bring bad package into your system. And of course, the dependency threads always, we have to make sure your open source component third party is up to date, and we don't accidentally bring in bad dependencies. So the attacks that could happen on this particular pipeline is basically because of dependency confusion issues and typo squatting. So what do we say about dependency confusion issues? Primarily, if we say, assuming it's a company like Yahoo, they are developing some internal components for their own local development, and an external attacker creates some packages in the name of Yahoo. So the class, when it comes during the build process, when it comes to the resolution of the classes and packages, the preference is given to the external package, and there's always a chance that the build might pick up the external package, which the attacker has crafted, and that can replace the local class definitions. Typo squatting is something very similar. So this is to confuse the developers pulling this open source from the internet. We can always mess up when we type certain dependency when we search. For example, Google, I might miss one O, and there could be a dependency that would come in accidentally. And to make sure this entire CI/CD pipeline is protected and supply chain dependency is properly checked for integrity and dependency checks, we all have to continuously do this red team testing. It could be automated as well as manual testing. So it's very, very important to carry out testing. So this framework basically is like a checklist, right? So it gives you some guidelines on what are the things that you can check. And SLSA actually has 4 levels, and it basically talks about the best practices that we can incorporate in the artifacts, especially provenance, with proper signature validations, proper integrity checks, and like a maker checker concept. And this is just an example of the SLSA requirements. For example, is it version controlled? Is it verified? Does it have verified history? Has 2% reviewed, and so on and so forth. So this is an example of the SLSA provenance, where you can see a digest. So one critical thing is the digest is generated using a key, and these keys should be properly stored within your crypto system, and that crypto system should be properly protected within your organization, right? So with that, we have provided some of the references here, which you can take a look, which will definitely come in handy. And with this, thanks for this opportunity, and thanks to Open Source 101 for giving us this opportunity and to present this. And this is just, these are all our thoughts and best practices based on our experiences. We would love to get your feedback our profiles are there in the open source 101 profile pages. So please do get connected through LinkedIn, and we are more than happy to answer any of the questions. Kavitha, you want to add anything if I missed?
No, I'm good. Thank you, Srini. And we both had a great time. And in the speakers page, like there are contacts, and please feel free to reach us. And thank you so much.
Thank you.